Hello students, today we will see some example on Gauss Jordan elimination method. So see this example, solve the following system of equation using Gauss Jordan elimination method. So they have given us a set of equations. So they have provided us three equations. So there are three unknowns in this equation. So first equation is 2x plus y plus 4z is equal to 12, 8x minus 3y plus 2z is equal to 23, 4x plus 11y minus z is equal to 33. So what we have to do in Gauss Jordan elimination method, we have to write this given set of equations into the matrix form, and after writing this into the matrix form, we have to form an augmented matrix of this A augmented B, and we have to make the matrix A as unit matrix. We have to convert the matrix A into the unit matrix, and finally whatever it will be left, that will be our answer. So see here, so first we have to convert the given set of equation into matrix form, that is Ax equal to B. So we have to write here only the coefficients in matrix A. See here, we have written only the coefficients. Matrix X is the unknowns. In this particular case, the unknowns are given as x, y, z. So we have written here x, y, z, and we have written here the matrix B as 12, 23, 33. 12, 23, 33. Now next step is we have to form an augmented matrix A augmented B. We have to add this column into the matrix A. So see here, it will become A augmented B. It can be written as, this is matrix A and we have written here matrix B. So see here, what we have to do, we have to convert this in matrix A into the identity matrix. So how to begin to do that? So you have already studied Gauss elimination method. In Gauss elimination method, we have converted the elements. We have converted the elements below the diagonal elements into 0. Now we have to make the elements below the diagonal as well as above the diagonals to 0. So we will begin with this first term only. Our first diagonal element is 2 here, so we have to make it as 1. We will make it as 1. So how to make it as 1? We have to divide it by 2. So we will perform R1 by 2. See here, we have performed here R1 by 2. So 2 by 2 is 1. 1 by 2 is 0.5. 4 by 2 is 2. 12 by 2 is 6. See here, only R1 has changed. The remaining rows are unchanged here. So next step is, with the help of this one, we have to make the element under this one, that is 8 and 4, to 0. So see here, I am applying two steps here, that is R2 minus 8 R1 as well as R3 minus 4 R1. So see here, whenever we are going to apply this R2 minus 8 R1, only R2 will get changed. Similarly, whenever we are going to apply R3 minus 4 R1, only R3 is going to change. So see here, so I have applied this row transformation. After applying this row transformation, see here, R2 has changed, R3 has also changed. See here, R2 earlier it was 8, so from 8 it has changed to 0. This minus 3, by applying this row transformation, it has become minus 7. This 2 has become minus 14. This 23 has become minus 25. Similarly, similarly for the row 3, this 4 has become 0. So our next step is, we have to make this second diagonal element as 1. Why we have to do this? In order to make this element that is 9 and 0.5 as 0. Always remember that we have to take the help of this diagonal element to make the elements either below the diagonal element as 0, or the elements above or below the diagonal elements to make them as 0. So we have to take the help of these diagonal elements. So see here, we are making this minus 7 as 1 here, and with the help of this one, we are going to make the elements above and below it as 0. So see here, we have to do this by R2 by minus 7. So by performing this, we will get only R2 will get changed. So this is already 0. Minus 7 by minus 7 is 1. Minus 14 by minus 7 is 2. Minus 25 by minus 7 is 3.5714. So see here. Now with the help of this one, we have to make this 0.5 and 9 as 0. So we will perform here R1 minus 0.5 R2. See here, we have to make this as 0. So it will become 0 when this same term will be subtracted from this term. So R1 minus 0.5 R2. Similarly, we have to make this 0. So R3 minus 9 R2. So after applying this, only R1 and R3 will get changed. So after applying this has become 0. Similarly, this particular two terms has also changed. So next step is, see here, we have to make this minus 27 to 1. This is third diagonal element. We have to make this as 1, and with the help of this, we have to make this 1 as 0, and we have to make this element as 0. See here, so we have applied here R3 by minus 27, and we get, see here, we have got here 1. We have divided this by minus 27. We have got here 0.8571. So with the help of this one, we are going to make the elements above this diagonal element, that is 2 and 1 to 0. So we will perform R1 minus R3. See here, this is already 1. So what should be subtracted from this? Only 1 will be subtracted from this. So we have written here R1 minus R3, and second it is R2 minus 2R3. See here, R2 minus 2R3. So after solving this, we have got here 1 0 0 0 1 0 0 1 0 0 1 1. So we have converted this to 0 0. Similarly, this particular two terms has also changed. Which terms? R1 and R2. So see here, we have converted this given set of equations into identity matrix, and this is nothing but our solution. So this is our identity matrix, that is I, and this is our matrix Z. So we have written here I augmented Z. So see the solution. So see the solution. We can write here Z is equal to 3.3571, 1.8571 and 0.8571. As x is equal to Z, as x is already equal to Z, we can also write here X matrix as XYZ, and Z is equal to these values. So we can write it as X equal to 3.3571 or Y equal to 1.8571 and Z equal to 0.8571. For today's lecture, we will conclude here. In next lecture, we are going to see some another methods as well as numericals. Till then, thank you.